Okay, here we go. Stand by. 3, 2, 1.
The thinking atheist. It's not a person. It's a symbol. An idea.
The population of atheists in this country is going through the roof.
Rejecting faith. Pursuing knowledge. Challenging the sacred.
If I tell the truth, it's because I tell the truth. Not because I put my hand on a book and made a wish.
And working together for a more rational world.
Take the risk of thinking for yourself. Much more happiness, truth, beauty, and wisdom will come to you that way.
Assume nothing. Question everything. And start thinking. This is the Thinking Atheist Podcast. Hosted by Seth Andrews.
The late astronomer and cosmologist and science communicator Carl Sagan wrote this in The Demon-Haunted World in 1995. He said, "Science is more than a body of knowledge. It is a way of thinking. I have a foreboding of an America in my children's or grandchildren's time when the United States is a service and information economy. When nearly all the key manufacturing industries have slipped away to other countries, when awesome technological powers are in the hands of a very few, and no one representing the public interest can even grasp the issues, when the people have lost the ability to set their own agendas or knowledgeably question those in authority, when clutching our crystals and nervously consulting our horoscopes, our critical faculties in decline, unable to distinguish between what feels good and what's true, we slide, almost without noticing, back into superstition and darkness. The dumbing down of America is most evident in the slow decay of substantive content in the enormously influential media. The 30-second sound bites, now down to 10 seconds or less, lowest common denominator programming, credulous presentations on pseudoscience and superstition, but especially a kind of celebration of ignorance. It's like Carl Sagan wrote it yesterday. It is the month of December, of course, and we lost this great man in the month of December back in 1996, which is one of the reasons that I wanted to talk about him today. Somehow, even in death, he remains one of the best science communicators on the planet. A March 2014 article by Joel Achenbach said, "No one has ever explained space in all its bewildering glory as well as Sagan did." He's been gone now for nearly 2 decades. That's going to be 3 now. But people old enough to remember him will easily be able to summon his voice, his fondness for the word billions, and his boyish enthusiasm for understanding the universe we're so lucky to live in. He led a feverish existence with multiple careers tumbling over one another as if he knew he wouldn't live to an old age. Among other things, he served as an astronomy professor at Cornell, wrote more than a dozen books, worked on NASA robotic missions, edited the scientific journal Icarus, and somehow found time to park himself repeatedly, arguably compulsively, in front of TV cameras. He was the house astronomer, basically, on Johnny Carson's Tonight Show. Then, in an astonishing burst of energy in his mid-40s, he co-created and hosted a 13-part PBS television series, Cosmos. It aired in the fall of 1980 and ultimately reached hundreds of millions of people worldwide. Sagan was the most famous scientist in America, the face of science itself. Another world-famous scientist, astrophysicist Neil deGrasse Tyson, was on the Star Talk broadcast, and he was talking about his own Carl Sagan encounter. Here's what he said.
My interest predated my knowledge of him. In that sense, my interests were sort of homegrown within me after a first visit to the Hayden Planetarium in New York City, my local planetarium, which is where I now serve as director. So that trip, I became starstruck So by age 11, as I've said before, I had an answer to that annoying question that adults ask kids. What do you want to be when you grow up? So I would say astrophysicist. So it was deeply anchored there. And meanwhile, I was in the astronomy club. I bought a telescope with money I earned by walking other people's dogs. Went to an astronomy camp over the summer. So I'm all in on the universe. And so I'm applying to colleges. And one of the colleges I applied to and who accepted me was Cornell. And Cornell is where Carl Sagan was a professor. And apparently, unknown to me, the admissions office said, he might still be hemming and hawing about this decision. Do you think you can help us? And they sent him my application. He read my application, saw that it was dripping with the universe, and he wrote me a letter, hand signed.
Wow.
It said, "Dear Neil, I see you're interested in the universe. So am I." I'm paraphrasing here, of course. Why don't you come visit the campus? I'll show you around to help you decide if you want to attend. And it was like, because he was already famous then.
Right.
All right. He'd been on the Tonight Show with Johnny Carson. And so he'd written books. So I knew about the guy. But who am I? I'm just a 17-year-old high school senior. Why? What? So I showed it to my parents. I said, let's do it. Yes. So I got on a bus from New York City to Ithaca, New York in December. And he meets me in front of his building. And by the way, it's on a Saturday. Nobody else was there, no support staff. And he shows me around and he does a badass thing. He did a no-look reach behind him and pulled one of his books that he then signed to me. So a no-look reach means you wrote so many books, no matter what you touch, it's going to be something you wrote. Okay? I still have that book, of course. It says, "To Neil, future astronomer, Carl." So I did all this, and we go for hours and hours, and then time is for me to go back to New York. He drives me to the bus station, and it begins to snow, not an uncommon reality in Ithaca. And as it began to snow, he said, I don't know if the bus will make it through. Here's my home phone.
Wow.
If the bus is stalled, can't get through, call me. You can spend the night with my family. And I thought to myself, who am I for him to treat me this way? What, why, who? And then you know what I said to myself the whole time? This is almost surreal. I said to myself, if I am ever as remotely famous as Carl Sagan, I will treat the next generation of students the way he has treated me.
You will hear Carl Sagan's voice in just a few. First, I want to read an article in Parade magazine back in September of 1989. I was going to read just a few paragraphs, but honestly, the more I got into it, the more I became convinced I should just give you the whole thing. It's going to take me well over 20 minutes to do so. Just think of it as a short-form Carl Sagan audiobook narrated by me. It's titled, "Why We Need to Understand Science. Ignorance of science threatens our economic well-being, national security, and the democratic process. We must do better." And it's interesting that this was written 35 years ago. Carl Sagan wrote this. As I got off the plane, he was waiting for me, holding up a sign with my name on it. I was on my way to a conference of scientists and TV broadcasters, and the organizers had kindly sent a driver. "Do you mind if I ask you a question?" he said as we waited for my bag. "Isn't it confusing to have the same name as that science guy?" It took me a moment to understand. Was he pulling my leg? "I am that science guy," I said. He smiled. "Sorry, that's my problem. I thought it was yours, too." He put out his hand. "My name is William F. Buckley." Well, his name wasn't exactly William F. Buckley, but he did have the name of a contentious TV interviewer, for which he doubtless took a lot of good-natured ribbing. As we settled into the car for the long drive, he told me he was glad I was that science guy. He had so many questions to ask about science. Would I mind? And so we got to talking. But not about science. He wanted to discuss UFOs, channeling, a way to hear what's on the minds of dead people. Not much, it turns out. Crystals, astrology. He introduced each subject with real enthusiasm, and each time I had to disappoint him. The evidence is crummy, I kept saying. There's a much simpler explanation. As we drove on through the rain, I could see him getting glummer. I was attacking not just pseudoscience, but also a facet of his inner life. And yet there is so much in real science that's equally exciting, more mysterious, a greater intellectual challenge, as well as being a lot closer to the truth. Did he know about the molecular building blocks of life sitting out there in the cold, tenuous gas between the stars? Had he heard of the footprints of our ancestors found in 4 million-year-old volcanic ash? What about the raising of the Himalayas when India went crashing into Asia? Or how viruses subvert cells? Or the radio search for extraterrestrial intelligence? Or the ancient civilization of Ebla? Mr. Buckley, well-spoken, intelligent, curious, had heard virtually nothing of modern science. He wanted to know about science, it's just that all the science got filtered out before it reached him. What the society permitted to trickle through was mainly pretense and confusion, and it had never taught him how to distinguish real science from the cheap imitation. All over America, there are smart, even gifted people who have a built-in passion for science. But that passion is unrequited. A recent survey suggests that 94% of Americans are scientifically illiterate. We live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology. This is a clear prescription for disaster. It's dangerous and stupid for us to remain ignorant about global warming, say, or ozone depletion, toxic and radioactive wastes, acid rain. Jobs and wages depend on science and technology. If the United States can't manufacture at high quality and low price products people want to buy, then industries will drift out of the United States and transfer a little prosperity to another part of the world. Because of the low birth rate in the 60s and 70s, the National Science Foundation projects a shortage of nearly 1 million professional scientists and engineers by 2010. Where will they come from? What about fusion, supercomputers, abortion, massive reduction in strategic weapons, addiction, high-resolution TV, airline and airport safety, food additives, animal rights, superconductivity, midget man versus rail garrison MX missiles, going to Mars, finding cures for AIDS and cancer? How can we decide national policy if we don't understand the underlying issues? I know that science and technology are not just cornucopias pouring good deeds out into the world. Scientists not only conceived nuclear weapons, they also took political leaders by the lapels, arguing that their nation, whichever it happened to be, had to have one first. Then they arranged to manufacture 60,000 of them. Our technology has produced thalidomide, CFCs, Agent Orange, nerve gas, and industry so powerful they can ruin the climate of the planet. There's a reason people are nervous about science and technology. And so the image of the mad scientist haunts our world, from Dr. Faust to Dr. Frankenstein to Dr. Strangelove to the white-coated loonies of Saturday morning children's TV. All of this doesn't inspire budding scientists, But there's no way back. We can't just conclude that science puts too much power into the hands of morally feeble technologists or corrupt, power-crazed politicians and decide to get rid of it. Advances in medicine and agriculture have saved more lives than have been lost in all the wars in history. Advances in transportation, communication, and entertainment have transformed the world. The sword of science is double-edged. Rather, its awesome power forces on all of us, including politicians, a new responsibility. More attention to the long-term consequences of technology, a global and transgenerational perspective, an incentive to avoid easy appeals to nationalism and chauvinism. Mistakes are becoming too expensive. Science is much more than a body of knowledge. It is a way of thinking. This is central to its success. Science invites us to let the facts in, even when they don't conform to our preconceptions. It counsels us to carry alternative hypotheses in our heads and see which best match the facts. It urges on us a fine balance between no-holds-barred openness to new ideas, however heretical, and the most rigorous skeptical scrutiny of everything, new ideas and established wisdom. We need wide appreciation of this kind of thinking. It works. It's an essential tool for a democracy in an age of change. Our task is not just to train more scientists, but also to deepen public understanding of science. How bad is it? Very bad. It's official, reads one newspaper headline. We stink in science. Less than half of all Americans know that the Earth moves around the sun and takes a year to do it, a fact established a few centuries ago. In tests of average 17-year-olds in many world regions, the U.S. ranked dead last in algebra. On identical tests, the U.S. kids averaged 43% and their Japanese counterparts 78%. In my book, 78% is pretty good. It corresponds to a C+ or maybe even a B-. 43% is an F. In a chemistry test, students in only 2 of 13 nations did worse than the U.S. Compared to us, Britain, Singapore, and Hong Kong were so high they were almost off scale, and 25% of Canadian 18-year-olds knew just as much chemistry as a select 1% of American high school seniors in their second chemistry course, and most of them in advanced programs. The best of 20 fifth-grade classrooms in Minneapolis was outpaced by every one of the 20 classrooms in Sendai, Japan, and 19 out of 20 in Taipei, Taiwan. South Korean students were far ahead of American students in all aspects of mathematics and science, and 13-year-olds in British Columbia in Western Canada outpaced their U.S. counterparts across the boards. In some areas, they did better than the Koreans. Of the U.S. kids, 22% say they dislike school. Only 8% of the Koreans do. Yet 2/3 of Americans, but only 1/4 of the Koreans say they are good at mathematics. How do British Columbia, Japan, Britain, and Korea manage so much better than we do? During the Great Depression, teachers enjoyed job security, good salaries, respectability. Teaching was an admired profession, partly because learning was widely recognized as the road out of poverty. Little of that is true today, and so science and other teaching is too often incompetently or uninspiringly done, its practitioners, astonishingly, having little or no training in their subjects, sometimes themselves unable to distinguish science from pseudoscience. Those who do have the training often get higher-paying jobs elsewhere. We need more money for teachers' training and salaries and for laboratories so kids will get hands-on experience rather than just reading what's in the book. But all across America, school bond issues on the ballot are regularly defeated. U.S. parents are much more satisfied with what their children are learning in science and math than are, say, Japanese and Taiwanese parents whose children are doing so much better. No one suggests that property taxes be used to provide for the military budget or for agriculture or for cleaning up toxic wastes. Why just education? Why not support it from general taxes on the local and state levels? What about a special education tax for those industries with special needs for technically trained workers? American kids don't do enough schoolwork. The average high school student spends 3.5 hours a week on homework. The total time devoted to studies in and out of the classroom is about 20 hours a week. Japanese fifth graders average 33 hours a week. But most American kids aren't stupid. Part of the reason they don't study hard is that they've received few tangible benefits when they do. Competency, that is actually knowing the stuff, in verbal skills, mathematics, and science these days doesn't increase earnings for average young men in their first 8 years out of high school, many of whom take service rather than industrial jobs. In the productive sectors of the economy, though, the story is different. There are furniture factories, for example, in danger of going out of business, not because there are no customers, but because few entry-level workers can do simple arithmetic. A major electronics company reports that 80% of its job applicants can't pass a fifth-grade math test, and that's an American, not a Korean fifth-grade test. The United States is already losing some $25 billion a year, mainly in lost productivity and the cost of remedial education, because workers to too great a degree can't read, write, count, or think. Parents should know that their children's livelihoods may depend on how much math and science they know. Now, while the kids are in school, is the time for them to learn. Parents might encourage their schools to offer and their kids to take comprehensible, well-taught advanced science courses. They might also limit the amount of mind-numbing TV their children watch. Those in America with the most favorable view of science tend to be young, well-to-do, college-educated white males. But 3/4 of new American workers between now and 2001 will be women, non-whites, and immigrants. Discriminating against them isn't only unjust, it's also self-defeating. It deprives the American economy of desperately needed skilled workers. Black and Hispanic students are doing better in standardized science tests now than in the late 1960s, but they're the only ones who are. The average math gap between white and black U.S. high school graduates is still huge, 2 to 3 grade levels. But the gap between white U.S. high school graduates and those in, say, Japan, Canada, Great Britain, or Finland is more than twice as big. If you're poorly motivated and poorly educated, you won't know much. No mystery here. Suburban blacks with college-educated parents do just as well in college as suburban whites with college-educated parents. Enrolling a poor child in a Head Start program doubles his or her chances to be employed later in life. One who completes an Upward Bound program is 4 times as likely to get a college education. If we're serious, we know what to do. What about college and university? There are obvious steps similar to what should be done in high school. Salaries for teachers that approach what they could get in industry. More scholarships, fellowships, and laboratory equipment. laboratory science courses required of everyone to graduate, and special attention paid to those traditionally steered away from science. We should also provide the financial and moral encouragement for academic scientists to spend more time on public education, lectures, newspaper and magazine articles, TV appearances. This requires scientists to make themselves understandable and fun to listen to. To me, it seems strange that some scientists who depend on public funding for their research are reluctant to explain to the public what it is that they do. Fortunately, the number of scientists willing to speak to the public and capably has been increasing each year, but there are not nearly enough. Virtually every newspaper in America has a daily astrology column. How many have a daily science column? When I was growing up, my father would bring home a daily paper and consume, often with great gusto, the baseball box scores. There they were, to me, dry as dust, with obscure abbreviations, WSSSO, W-L, AB, RBI, but they spoke to him. Newspapers everywhere printed them. I figured maybe they weren't too hard for me. Eventually, I got too caught up in the world of baseball statistics. I know it helped me in learning decimals, and I still cringe a little when I hear that someone is batting 1,000. But 1.000 is not 1,000. The lucky player is batting 1. Or take a look at the financial page. Any introductory material, explanatory footnotes, definitions of abbreviations? None. It's sink or swim. Look at those acres of statistics. Yet people voluntarily read the stuff. It's not beyond their ability. It's only a matter of motivation. Why can't we do the same with math, science, and technology? By far, the most effective means of raising interest in science is television. There's lots of pseudoscience on TV, a fair amount of medicine and technology, but hardly any science, especially on the big three commercial networks, whose executives think science programming means ratings declines and lost profits, and nothing else matters. Why in all America is there no TV drama that has as its hero someone devoted to figuring out how the universe works? Stirring projects in science and technology attracts and inspires youngsters. The number of science PhDs is peaked around the time of the Apollo program and declined thereafter. This is an important potential side effect of such projects as sending humans to Mars or the superconducting super collider to explore the fine structure of matter or the program to map all human genes. Every now and then I'm lucky enough to teach a class in kindergarten or the first grade. Many of these children are curious, intellectually vigorous, ask provocative and insightful questions, and exhibit great enthusiasm for science. When I talk to high school students, I find something different. They memorize facts, quote-unquote facts, but by and large, the joy of discovery, the life behind those facts has gone out of them. They're worried about asking dumb questions. They're willing to accept inadequate answers. They don't pose follow-up questions. The room is awash with sidelong glances to judge, second by second, the approval of their peers. Something has happened between 1st and 12th grade, and it's not just puberty. I'd guess that it's partly peer pressure not to excel, except in sports. Partly that the society teaches short-term gratification. Partly the impression that science or math won't buy you a sports car. Partly that so little is expected of students. And partly that there are so few role models for intelligent discussion of science and technology or learning for its own sake. But there's something else. Many adults are put off when youngsters pose scientific questions. Children ask why the sun is yellow, or what a dream is, or how deep you can dig a hole, or when is the world's birthday, or why we have toes. Too many teachers and parents answer with irritation or ridicule, or quickly move on to something else. Why adults should pretend to omniscience before a 5-year-old, I can't for the life of me understand. What's wrong with admitting that you don't know? Children soon recognize that somehow this kind of question annoys many adults. A few more experiences like this, and another child has been lost to science. There are many better responses. If we have an idea of the answer, we could try to explain. If we don't, we could go to the encyclopedia or library. Or we might say to the child, I don't know the answer. Maybe no one knows. Maybe when you grow up, you will be the first to find out. But mere encouragement isn't enough. We must also give children the tools to winnow the wheat from the chaff. I'm haunted by the vision of a generation of Americans unable to distinguish reality from fantasy, hopefully clutching their crystals for comfort, unequipped even to frame the right questions or to recognize the answers. I want us to rescue Mr. Buckley and the millions like him. I also want us to stop turning out leaden, incurious, unimaginative high school seniors. I think America needs and deserves a citizenry with minds wide awake and a basic understanding of how the world works. Public understanding of science is more central to our national security than a half a dozen strategic weapon systems. The sub-mediocre performance of American youngsters in science and math, and the widespread adult ignorance and apathy about science and math should sound an urgent alarm. And again, this is from a reprint of a 1989 article in Parade magazine, Why We Need to Understand Science. You can feel the fact that it's a 35-year-old article in some ways as he talks about the 3 major television networks and the reading of newspapers. But beyond some of those details, it is alarmingly close to the bullseye as we head into 2025. Let me take a short break and we'll come back and listen to the actual voice from recordings, interviews, speeches, Q&As featuring Carl Sagan next. This month, I just thought maybe you and I could benefit from hearing the calming voice, the wonderfully educated voice, the inspired voice of the late, great Carl Sagan. This storyteller of science died of cancer on the 20th of December, 1996. He was only 62 years old. Yet fortunately for us, his writings and his voice and his work live on thanks to the very technology that he so often wrote and spoke about. May 27th, 1996, he was being interviewed on The Charlie Rose Show about science and science literacy, or lack of.
My feeling, Charlie, is that it's not that pseudoscience and superstition and New Age so-called beliefs and fundamentalist zealotry are something new. They've been with us for as long as we've been human. But we live in an age based on science and technology with formidable technological powers.
Science and technology are propelling us forward at accelerating rates.
That's right. And if we don't understand it, by we I mean the general public, if it's something that, oh, I'm not good at that, I don't know anything about it, then who is making all the decisions about science and technology that are going to determine what kind of future our children live in? Just some members of Congress? But there's no more than a handful of members of Congress with any background in science at all. And the Republican Congress has just abolished its own Office of Technology Assessment. the organization that gave them bipartisan, competent advice on science and technology. They say, we don't want to know.
Same interview just a few minutes later, Charlie Rose asked Carl Sagan about religion. This clip runs about 3 minutes.
It's after the way the universe really is and not what makes us feel good. And a lot of the competing doctrines are after what feels good and not what's true.
Okay, but you got to make, I'm not sure you'll go this far with me, but I mean, there's a lot of that is about feeling good, and there's a lot of that that's about hocus pocus. But at the same time, there are millions of people who understand science does not prove religion, but because religion is faith-based. And therefore, you should not deny the value of it because it is faith-based and not scientific.
But let's look a little more deeply into that. What is faith? It is belief in the absence of evidence. Now, I don't propose to tell anybody what to believe, but for me, believing when there's no compelling evidence is a mistake. The idea is to withhold belief until there is compelling evidence. And if the universe does not comply with our predispositions, okay, then we have the wrenching obligation to accommodate to the way the universe really is.
So you step forward to say, I deny all religion because I can't see it proved scientifically?
No. You see,
the value of religious experience and the value of reaching for higher experiences.
Let me say, religion deals with history, with poetry, with great literature, with ethics, with morals, including the morality of treating compassionately the least fortunate among us. All of these are things that I endorse wholeheartedly. Where religion gets into trouble is in those cases that it pretends to know something about science. The science in the Bible, for example, was acquired by the Jews from the Babylonians during the Babylonian captivity of 600 BC. That was the best science on the planet then. But we've learned something since then. Roman Catholicism, Reformed Judaism, most of the mainstream Protestant denominations have no difficulty with the idea that humans have evolved from other creatures, that the Earth is 4.6 billion years old, with the Big Bang. They don't have any trouble with that. The trouble comes with people who are biblical literalists, who believe that the Bible is dictated by the creator of the universe to an unerring stenographer.
And so therefore they...
And has no metaphor or allegory.
And from there they make their political and economic choices. And social choices.
And scientific.
And scientific choices. And scientific. And that's part of your problem with that idea.
Exactly.
It is that because for the wrong reasons we make the wrong choices about science.
That's right. So who is more humble? The scientist who looks at the universe with an open mind and accepts whatever the universe has to teach us, or somebody who says everything in this book must be considered the literal truth and never mind the fallibility of all the human beings involved in the writing of this book?
In the article I read at the beginning of the broadcast, Carl Sagan talked wistfully about perhaps exploring Mars. And I know this is a hot one in the age of Elon Musk and SpaceX. Here is Sagan talking about Mars. This was from 1988. It was part of a program called God, the Universe, and Everything Else. He was on stage with Stephen Hawking and Arthur C. Clarke. The host asked this question.
Now, it's very nearly 20 years ago since man landed on the moon. Do you think that we've basically stopped trying to get man any further? Is there any chance that another Neil Armstrong will set foot on Mars in our lifetime?
The United States and the Soviet Union have managed to booby-trap the planet with about 60,000 nuclear weapons, with a little help from Britain, France, China, and Israel. A tiny fraction of those weapons is enough to destroy the participating nations, certainly, the global civilization possibly, and the human species just maybe. It is now time for the United States and the Soviet Union to demonstrate that they can undo this specter, that they can demonstrate their ability to work together on high technology for peaceful, hopeful purposes that carry us into a benign 21st century. And that is why I support the idea of joint U.S.-Soviet cooperation in the exploration of Mars, leading up to an international manned, and by the way, womaned mission to the planet. Americans and Soviets, as representatives of the human species, other nations, I presume, would also be involved. And then a glorious, whatever it would be, few-month period in which Mars, I have a globe of it right next to me, in which Mars would be explored. There are hundreds of ancient river valleys on Mars. Mars is today bone dry. It was once much warmer, much wetter, much denser atmosphere, much more Earth-like. What were those conditions like? Why did an Earth-like planet get converted into this deep ice age condition that Mars has today? And is there life there? Could there once have been life? Are there fossil forms? There are extraordinary, enigmatic geological features on the planet. What is their nature? There is a huge amount of exploration to do, and all of it, every step that I've described, could be before the television cameras of the world, and we could all participate in such exploration.
Now, again, that was 1988. It's interesting to think about what Sagan might say. Rovers on Mars, cruising around, taking samples, sending us photos and video from the surface of Mars. What would he have thought about this idea that Elon Musk has, colonizing Mars? Especially given all the needs that we have here on the planet. But I found most interesting him referencing the Soviet Union. This was pre-perestroika. So it was the United States versus Soviet Russia, the Cold War and all that underway. What if he could look forward to 2024 and see what's going on with Putin and everything else? This crazy situation, global strife, and Putin acting in such destructive ways. Would he have been so optimistic about us joining forces, a shared humanity, to explore another planet, and in doing so, explore ourselves? I don't know. Here is Sagan. This was from a lost lecture from 1994, recently recovered. He was doing some Q&A at a university, and somebody asked him about finding meaning in our lives.
You see, the idea that our sense of self-worth comes not from anything that we've done, not from anything worthy, but by an accident of birth, is where the crux of the humiliation is, in my opinion. I would say those of us worried about being demoted, those of us who wish for us to be important, should do something important. We should make an easily understandable, achievable, and inspiring goal for the human species, and then set out and do it. That would give us the confidence that we sorely lack by being dependent on our self-esteem being based on nothing we do. We want to have self-esteem? Let's make a planet in which nobody is starving. Let's make a planet in which men and women have equal access to power. Let us make a planet in which no ethnic group has it over another ethnic group. Let's have a planet in which science and engineering is used for the benefit of everybody on the planet. And my personal idiosyncrasy, let's have a world in which we go to other worlds.
Same event from 1994. During the Q&A, someone in the audience asked Carl Sagan about the existence of God. There's quite a bit of the audio from the questioner, and then Carl Sagan takes over.
As we kind of make God almost go away through these demotions, and I don't mean he, because who knows what God is, but
still saying it makes it
right.
sort of icky, doesn't it?
Yeah, it's tough.
We like it to be a he, don't we?
Yeah. We've been trained to think of it as a he. It seems that through the ages, humans have created a mythological framework that has always involved often involves some kind of higher spiritual powers. And as
every human culture has done that.
As that goes away, as we know more and more that, and it seems harder and harder to prove that anything might exist like that, where does that leave us?
On our own. Which to my mind is much more responsible than hoping that someone will save us from ourselves so we don't have to make our best efforts to do it ourselves. And if we're wrong, and there is someone who steps in and saves us, okay, that's all right. I'm for that, but we, hedged our bets. It's Pascal's bargain run backwards. I'll say another word. The word God covers an enormous range of different ideas, and you recognize that in the way you phrase the question. Running from an outsized, light-skinned male with a long white beard sitting in a throne in the sky and tallying the fall of every sparrow, for which there is no evidence. To my mind, if anybody has some, I sure would like to see it. To the kind of God that Einstein or Spinoza talked about, which is very close to the sum total of the laws of the universe. Now, it would be crazy to deny that there are laws in the universe, and if that's what you want to call God, then of course God exists. And there are all sorts of other nuances. There is, for example, the deist God that many of the founding fathers of this country believed in, although it is a secret whose name may not be spoken in some circles. A roi fainéant, a do-nothing king, the God who creates the universe and then retires, and to whom praying to is sort of pointless. He's not here. He went somewhere else. He had other things to do. Now, that's also a God. So when you say, do you believe in God? If I say yes or if I say no, you have learned absolutely nothing.
I guess I'm asking you to define yours if you have one.
But why would we use a word so ambiguous that means so many different things?
It gives you freedom to define it.
It gives you freedom to seem to agree with someone else with whom you do not agree. It covers over differences. It makes for social lubrication. But it is not an aid to truth, in my view.
Now, Sagan was called to testify before Congress, 1985. This was a year before I graduated high school, before many of you were born. But the climate effect, climate change, these were already starting to become big conversations, at least in the scientific community. And Carl Sagan was right there at the front of this. He was sitting in front of a bunch of congressmen trying to explain the greenhouse effect. And he expressed it in a way that, for me, for one of the first times, made sense. This was a way for me to be able to play along. I'm hoping that congressmen understood, even if Congress hasn't done much about it. This is a longer clip. Carl Sagan, The Greenhouse Effect, 1985.
If you ask what determines the Earth's climate, clearly the main thing that determines it is sunlight. Sunlight is what heats the Earth. Not all the light that arrives at the Earth from the sun goes to heating the Earth. Some of it is reflected back. It's just the part that is absorbed. And what happens is there's a certain rate at which sunlight is absorbed by the Earth's surface, and there's a certain rate at which the Earth's surface radiates to space. What comes from the sun is in the ordinary visible part of the spectrum that our eyes are sensitive to. What the Earth radiates into space is in the infrared part of the spectrum, longer waves than red, that our eyes are not sensitive to, but it's as legitimate a form of light as the kind that we're used to. Now, if you calculate what the temperature of the Earth ought to be from how much sunlight is being absorbed, equaling how much infrared radiation would be radiated to space, you find that the Earth's temperature, by this simple calculation, is too low. It's about 30 centigrade degrees too low. Why is it too low? It's too low because something was left out of the calculation. What was left out of the calculation? The greenhouse effect. The air between us is transparent, except in Los Angeles and places of that sort, in the ordinary visible part of the spectrum. We can see each other. But if our eyes were sensitive at, say, 15 microns in the infrared, we could not see each other. The air would be black between us, and that's because, in this case, carbon dioxide. Carbon dioxide is very strongly absorbing at 15 microns and other wavelengths in the infrared. Likewise, there are parts of the infrared spectrum where water vapor absorbs, where we could not see each other if we were only as far apart as we are in this room. If you add these infrared absorbing gases to a planet, then what happens is the sunlight comes in as before, but when the surface tries to radiate to space in the infrared, it is blocked, it is impeded by the absorbing gases. And so the surface temperature has to rise so that there is an equilibrium between what comes in and what goes out. So this is the greenhouse effect. It is a misnomer for more reasons than one. It's a misnomer in particular because that's not how the florist greenhouse works, but that's a very minor point. There are other gases which absorb in the infrared, many of which have been mentioned already: nitrous oxide, methane, the halocarbons. And these are products partly of agriculture, it's fertilizers, refrigeration, aerosol spray cans, and so on, all products of our technology. We don't generate much water into the atmosphere, but we certainly do generate a great deal of carbon dioxide through the burning of wood and fossil fuels, an apparently benign activity. Who could object to humans burning oil and coal, gas, and wood? I'd like to stress that the greenhouse effect makes life on Earth possible. If there were not a greenhouse effect, the temperature would, as I say, be 30 centigrade degrees or so colder, and that's well below the freezing point of water everywhere on the planet. The oceans would be solid after a while. A little greenhouse effect is a good thing. But there is a delicate balance of these invisible gases, and too much or too little greenhouse effect can mean too high or too low a temperature. And here we are pouring enormous quantities of CO2 and these other gases into the atmosphere every year with hardly any concern about its long-term and global consequences.
Okay, we can't talk about Carl Sagan without doing a pale blue dot, right? Let me take one last break and we will come back with arguably the most famous words he ever wrote and spoke after this. If I can, I want to leave on a high note. Carl Sagan's arguably most famous work was inspired by the photograph taken by Voyager 1 on the 14th of February 1990. A vast photograph, and this tiny little dots that we see, almost invisible, and that dot, of course, is us, the pale blue dot. Carl Sagan actually wrote a book by that title in 1994. I took the liberty of taking his voice and doing a video interpretation of a pale blue dot. This is the audio of that, and it's what I will leave you with today.
Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, Every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on the mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.